So my Gyll brand 24 volt 200 amp hour batteries arrived today, and so they come in a big box here, about 100 pounds a piece, and then they will mount in this handy server rack with bus bars that is also available from the manufacturer. So I'm just kind of showing that we're moving this from this box, about 100 pounds, and then I got to get that battery into the second slot in this rack. And so this rack actually holds 3 batteries, and so I have 3 200 amp hour batteries, which is going to give me a total of 600 amp hours, approximately 5100 watts a piece, so about 15 kilowatt hours of battery capacity when I get this installed. So after a little bit of heavy lifting, I was able to get the 3 batteries into the 3-space rack here, and they look really nice. They have a nice stainless steel hardware, and the only thing that I've kind of noticed is that on this bus bar is that one of the stanchions didn't actually line up with the hole in the bus bar, the threaded hole in the bus bar. So I wasn't able to get that screw in there without stripping it out. It's also held here on this one and on that one there. And then on the other side, they did go ahead and line up. So that's the only thing that I've kind of discovered so far. I'm really happy with the enclosure, the rack. It has a nice handle that turns and closes and is lockable. And you can just press that and then turn this, open it up, and there's the rack. Okay, so the next step tomorrow will be actually doing the wiring to the bus bars, equalizing the charge on the batteries, hooking up the computer controls, and then eventually we'll be able to hook up the main power cables up to the junction box up here and make the batteries live. Okay, so I'm working on the installation of the batteries here into the rack, and I went ahead and I tested each one of the batteries for their voltages to make sure that they were fairly close and wouldn't need equalization. And I actually came up with some figures here, and they're all about 32.9 volts at this point when they ship to me. One of the things that I found when I was working with the rack here is that these bus bars, I initially attached them with the threaded holes here to the standoffs, and then I found that that I wouldn't have enough screws to actually mount to connect the batteries. And I realized that they had a drill through with unthreaded for these screws to go into the standoffs. Unfortunately, the standoffs and the bus bar weren't exactly aligned for the center standoff, and so they're basically off of a few millimeters there, and so I was able to attach the bottom and the top standoff on the bus bars, but I wasn't able to attach the center standoffs because they were misaligned. Okay, the next step will be to go ahead and then wire from the battery to the bus bar. And so we'll go from each one of these points to the threaded connection here. and then eventually we'll take these here and then go with the 4-wire gauge 4-aught, and that will hook to the charge controller and the inverter. Okay, so now I've connected the hot and negative wires to the bus bars here, and so we've got some cables that were supplied with the batteries, and these are there are 16 millimeter square cables, which I think is roughly equivalent to 6 gauge AWG. And so we've attached these 3 to the bus bars from the battery terminals here, and you can see that we have double terminals, and that would be, if you wanted to, you could go ahead and just parallel with them battery to battery to battery, and then to a bus bar or to your charge controller or loads if you didn't have this bus bar. So the bus bar just makes it a little bit more convenient and makes for a really kind of neat installation, and they have these little clear plastic covers that go onto the terminals here, I guess to prevent arcing, but again, it makes it just kind of look elegant. So our next connection is going to be our data connections, and so what we're going to do is basically run these Ethernet cables between each of the batteries, and then from the batteries to the computer. And so that will be the next step that I'll show you. Okay, so now I've hooked up the data to these to the batteries here. So there's a battery COM port here, and it really doesn't matter how you which input and output you put in here. It's just kind of, I like kind of being neat and have that be the comes outa, and that the Gazenta comes outa, Gazenta comes outa, and then this goes up and through an Ethernet cable that we modified according to the instructions from the battery manufacturer, and there's a little USB interface that goes from the RS485 to USB. And so I went ahead and purchased one of these from Amazon, but they do supply you with one when you purchase the battery. So if this one fails, then I've got this one. Okay, so I've got my cheap little laptop up here, and then I've got the BMS Tools software installed from the Signature Solar site, and I'm about ready to do what I call the first smoke test, in which we'll switch these batteries on, and then I'll connect up the USB to the computer and see if they recognize the batteries. Alrighty, so we'll go ahead and big moment of truth here. Turning on battery 3, battery 2, battery 1. It should note that we have a little addressing dip switches here, and so these are basically set up to be binary code for 1, 2, and 3, and so that should show up in the software as batteries numbers 1, 2, and 3. Okay, so we don't have any smoke at this point, and so I'm going to go ahead and plug in the USB. So I was unable to get the BMS software to work at this point, and that's going to take a call to customer support at Signature Solar. I went ahead and I switched out the USB adapter, re-downloaded the drivers, re-downloaded the software, reinstalled the drivers, reinstalled the software, and we're still getting a serial port error. So I'm going to move on beyond that, and what I've done is I've disconnected my battery bank here, the 8L16 lead acid batteries, and rerouted the 4/0 welding cable to the Gyll batteries, and then I've attached that to the bus bar here with the provided screw, and I removed the two upper screws so that the ring terminal on the 4/0 gauge would have as much contact with the bus bar as possible. And so I've also here I've attached the negative terminal and did the same thing, and then we went ahead and we fired up the batteries, and they all have they're showing running and a state of charge, and you can see that they're actually the data ports are showing activity as well, and so I'm not quite sure why the software is not working. So we've routed this into our junction box here, and or DC disconnect overcurrent module in trace engineering terms. And then we moved on over here to the Outback FM60 charge controller. And so what I did with that is I set the settings so that the absorption voltage was 28.2, and then the float voltage, which of course you really don't need to float lithium batteries, is now set to 26.6. I'm hoping that those are the correct settings. I've tried several YouTube movies on the internet and did a search, and that was kind of the best answer that I came up with for setting on this FM60 for these batteries. Right now we still have our Bogart Engineering battery monitor here, and so I can get a little bit of an idea of what's going on with the batteries. They're reading at 26.5 volts, and right now we're charging at 8 amps, and we're putting out 4 amps to the inverter. So I mean, the inverter is taking up 3 of those amps to the and so the 4 amps are going to the battery. We are actually in a float state right now, which means that the batteries are not charging. They are just basically sitting there at that voltage. What I'm hoping to see here is that we'll start to see some charging and start to see some bulk, and then it would go to an absorption level at 28.2 volts. So I hope I'm doing that part right, and so we'll see as the day goes on, and I'm going to do some more research. So overall, so there is my Gyll battery install, and so the next step will be replacing the inverter and adding an additional charge controller. So this is an update on the data communication for these 24 volt Gyll lithium-ion batteries. In the previous version of these batteries, there were only 2 ports per battery, which was basically a RS-485 bus. And the latest version has 4 ports. So they have a CAN port, RS-485, and 2 battery dash COM ports. Okay, and previously the recommended configuration was to use these jumper cables to jumper data, daisy chain data between the batteries, and then have a cable, the Ethernet cable, that went to a serial to USB converter to the BMS software. Unfortunately, this configuration does not work anymore. Okay, so the battery COM channels have changed, and basically in my conversation with Signature Solar and their technical support people, James at Technical Support, is that with the new version, the only thing that works is with the BMS software is if you connect to the RS485 connector here. So if I go ahead and rescan my ports, search devices here, and then I have to dismiss this error here first. Okay, so this will rescan, and it will basically come up with this device again. Okay, and so as it rescan, you'll see that now that it only recognizes pack 2. Okay, so it's not recognizing the other 2 batteries that are daisy chained here together. So right now, the way that this works is that you can only monitor one battery at a time by changing the Ethernet cables. And so these daisy chain cables are basically useless at this point. And so I'm going to go ahead and disconnect them. Okay. Second important thing that we found during the troubleshooting session to get things to work is that you do not want to set your battery dip switches so that pack 1 is enabled. So you want to start with your dip switches at pack 2. So if the dip switch configuration is 1 down, 2 down, 3 up, 4 down. Okay, and that is the binary number 2. And then I've got the next battery addressed as binary 3, which is 1 down, 2 down, 3 up, 4 up. And then finally, this one is addressed as battery number 4, which is 1 down, 2 up, 3 down, 4 down. And so now the BMS software does work and recognize the batteries, and I'm able to monitor the batteries. Okay, this is Jay from Sagebrush Journal, and you can subscribe to this channel to watch more videos about off-grid living, and you can also like the video. I appreciate it.